Greetings everyone. So in the last lecture we read about the types of functions, and now we will know the mathematical approach to solve questions regarding different types of functions, or the questions that will ask you to prove whether the function is bijective or not. So let us quickly recall and once again clear the concepts of one-one, many-one, into and onto functions. So see, one-one and many-one functions are concerned to your domain. Keep this in mind, this is very crucial, that one-one and many-one function will be focused to your domain, and the concern in into and onto function is with the codomain of the function. See how, if suppose there is a mapping like this, and where every element is mapped, only one element is mapped to an element of codomain. See, only one is mapped to A. It could also happen that 1 and 2 both were mapped to A, but no, in one-one function only one element will be mapped to one element of the codomain. These kinds of functions are called one-one function. And what differs one-one function from many-one function is that in many-one function more than one element is mapped to a single element of the codomain. Suppose 1 is also mapped and 5 also. Suppose 1 is also mapped to A and 2 is also mapped to A, and suppose 3 is also mapped to A. Similarly 4 is mapped to this and 5 is mapped to this. Now you see, how is one-one different from many-one? You see, in one-one only one element is mapped to one element of the codomain, but in many-one function more than one functions are mapped to only one element of the codomain. So this is how one-one differs from many-one. Keep this in mind, this is very crucial. Now in onto and into function, your focus will be simply on the codomain. What you have to do is to just check whether all the elements of the codomain have pre-image in the domain or not. Suppose in an into function, suppose this is a mapping. Suppose the mapping is done like this. You see, your focus should only be on the codomain. You see here one element does not have pre-image in A in your domain, so this is an into function. But when all the elements have pre-image, no element in the codomain is left that does not have pre-image in the domain, then that kind of function is an onto function. Suppose it's like 1 2 3 4. Now you see, every element, suppose it's this kind of function where every element, this 4 and 5 both are mapped to D. Now you see, in this kind of function, you look at the codomain, all the elements have pre-image, either 1 or 2 or maybe 3 or maybe 4, but every element of the codomain has an image in the domain. This is onto function. But even if one function is left that does not have image in the codomain, then you will say that is an into function. This is the complete difference between onto, into, one-one and many-one. So your focus in one-one and many-one function is only on the domain. Keep this in mind, this is very important. Just in one-one and many-one function, you just have to look at the domain, and in into and onto function, you just have to look at the codomain and see the mapping carefully. This is all about one-one, many-one, into and onto function. Now in the same question, if they ask you whether the same function is an onto function or not, so what will you do? See, for onto, you know that every y should have a pre-image in X, right? If you are able to get any y in the codomain that does not have pre-image in X, then your function is not onto. So basically what you have to do here is find the inverse of the function fx. Means the function is in the form of x. First you will convert it into a function of y. See how? Let us say your fx is x square. Let us say fx is equal to y. So what do you get? X square is y, and your motto is to convert it into the form of y, right? Make it do the square root both the side. What will you get? You will get x is equal to y to the power 1 by 2. All right. So suppose we give this function y to the power 1 by 2 a name g of y. Alright, So now you see what you got. Your g of y is equal to y to the power 1 by 2. Means let us say g of y is x. Now you started from a function of x and you came to a function of y. G of y is equal to x, means g of y has the value y to the power 1 by 2. Alright, see, your function has become your function was initially a function of x, but now it has become a function of y. So this is the crucial step that you have to follow in the first place, that convert the function of x into a function of y. So now you have shifted your solution to the codomain. Now what you have to do to find whether a function is an onto or not? You just have to find any one, even a one contradiction that does not satisfy will lead the function to be an onto will lead the function to not to be an onto function. See, if you are able to find even one y, suppose any one y here in the set of real number that does not have pre-image in x, so your function is not going to onto. What your function is? Y to the power 1 by 2. Now let us find any element in the real number set. See, you cannot check this for all the real numbers because real numbers are infinite in nature. So what you are going to do is to find a contradiction. See, you know that let us say let y is equal to -1. We will take y as -1 because y has to belong to real number and -1 is a real number. Let us take y as -1. So what your g of y, your function is going to become? Your function is going to become -1 of -1 to the power 1 by 2. Suppose we are going to take g of -1. So your function is going to become -1 to the power 1 by 2, which is what? Which is iota, right? And iota is a complex number. It does not belong to your codomain real number, right? So what did you get? If you put -1, if you take -1 from this codomain, you are not going to get any value in the domain. For -1 you don't have any pre-image, so you got a contradiction. Now you know according to the mapping your -1 is left free with no pre-image, so your function is not an onto function. So let me repeat it once again. Basically what you have to do is just take your function, convert the function of x into a function of y, and then just find one contradiction where this is not going to satisfy. So your function will become an onto function. Look at this very carefully. This is how you have to proceed in all the other examples where you have to prove whether the function is onto or not. Alright, so let us look at this question. Your fx is a function from real number to real number and your function is greatest integer function. This is your greatest integer function. I guess greatest integer function. I guess you know what greatest integer function is. Okay, let me just recall. See, your greatest integer function is where, like, suppose let me tell you, -1 when smaller than x is smaller than 0, 0 when 0 is smaller than x is smaller than 1, and we go like 1 when x is smaller than 1 is smaller than 2, and so on. So see, what greatest integer function does is basically whenever you are given any decimal, suppose 0.89, and if you apply greatest integer function, what it will do, it will convert it into the greatest integer that is included in this number. So see, the greatest integer is what? 0 only. It is 0 plus what it is? It is 0 plus 0.89, or suppose it was 1. So how can this be written? This can be written as 1 plus 0.89. So your greatest integer included is 1. So this function will convert these kinds of decimals into greatest integer. So your answer will be 1. Suppose it's 0.08. So your greatest integer function is going to be 0 only. Suppose it is minus of 0.06. So it's going to be -1 only, because what it is. Alright, so this is how greatest integer function works. So let us see if it is onto and 1 1 and onto. Alright, so See, basically what we have to do here is just find contradictions. Let me just explain this graphically or diagrammatically. You see, suppose it is 0 point, this is a set of real number, this is also a set of real number. Suppose it is 0.1, suppose this is 0.2, 0.3 up to all 0.9. What you are going to get, all of them are going to be mapped to 1 only, right? Because for all this value, if your function is greatest integer function, for all such numbers you are going to get the value 0 only. So what do you see? Is it a 1 1 function? No, because many are mapped to one element. This is many to one function, so obviously this is not a bijective function, right? You see, from all the elements, let me make it a bigger one. Suppose you see, from all 1.01 to all the element up to 1.99, all will have the image 1 only, right? So this is a many to one function. So your function being 1 on 1, the possibility is completely ruled out. Now let us check if the function is onto. As such, we need not check, because if the function is not 1 1, then the function is not going to be on bijective. But let us just, for our own understanding, let us just check. Now you see, your function is converting real numbers into integers, right? Greatest integer function. All the decimals will be converted into what? Integers. So you see, suppose your 1 1, 0.1, 0.2 and all of them are mapped to 1. suppose let us say 1.5, 1.6, all these will be mapped to this is going to be mapped to 0, actually this is going to be mapped to 1. Now you see, suppose there is 0.5, you won't have any pre-image for 0.5 or any decimal number for that matter. You are not going to get any pre-image, because your function itself is converting all the numbers, decimals, into integers only. So from the set of real number, the decimals, they are not going to have any pre-image in the domain, so obviously they are going to be left out. The function is not an onto function, right? So this function is not a bijective function at all. Now you see how you have to solve this. Suppose when in these kinds of function where it's very easy to find the contradiction, then you don't have to go for all that conventional method where for 1 1 you have to prove if fx1 is equal to fx2, then x1 is equal to x2. You don't have to prove this. You just find one contradiction in between, and your function is not 1 1 and onto.